Assalamu alaikum and welcome back to Learn with Mafaza. In the previous videos, we covered data cleaning techniques, filtering rows and columns, and organizing data effectively using Pandas. If you missed those, be sure to check out the early parts of this series. Today, we are going to see some essential techniques in data manipulation, like dropping column, filtering columns, and grouping based on condition and sort values. Likewise, we are going to see some techniques. Sometimes dataset contain columns that are unnecessary or irrelevant for your analysis. Dropping these columns helps streamline your dataset and focus on the data you need. By default, the drop function returns a new data frame without modifying the original. If you want to make the change permanent, add in place equal true like this df.drop columns equal to under square bracket total a comma in place equal true. After dropping the column, I am going to see the output using df.head. You can use any output, head or tail, whatever. So here you can see the total column has been removed from the data frame. There is another way to drop the column also. Instead of using df.drop columns equal column name, here I am going to use df.drop column name, comma axis equal 1. Axis equal 1 means column. If I use axis equal 0, that is mean rows. Already we have removed a column name total. Now I am going to add a new column to our data frame name total. So here is the code df total equal df quantity multiplied by df price. Here you can just use the total name, any column name. Instead of total, you can use any column name. So this creates a new column called total, where each row contains the product of quantity and price. Running this code updates the data frame to include the total price for each product. It's quick and simple with Pandas. So similarly, you can create a new column just by defining the column name like df total or whatever name. Next, let's see about sorting. To sort the data by a single column in ascending order, we can use the sort values method. Here is the code df.sortValues by equal price, comma in place equal true. By equal price specify that we are sorting the data based on the price column. Here you can put whatever column name. In place equal true applies the sorting directly to the original data frame. After running this code, the data frame will be reordered so that the rows with the lowest prices come first, followed by higher prices. Sorting data like this is useful when you want to analyze trends or focus on specific ranges in your data set. Let's talk about sorting a data frame in descending order by a single column and the difference between using in place equal to or assigning the results to a variable. Here is the code: sorted value equal df dot sort values by equal product, comma, ascending odd, ascending equal false. In this example, by equal product specify that we are sorting the data frame by the product column, and ascending equal false means sorts the data in descending order. The results is stored in the variable sorted value. Now when you call sorted value, you will see the sorted data frame with products in descending order. This method allows us to work with the sorted version without affecting the original data frame. If you want to modify the original data frame, use in place equal to if you want to modify the data frame directly. If you prefer to keep the original data unchanged, assign the result to a new variable. Sorting data is essential for organizing and analyzing trends. Whether you update the data frame or create a separate variable depends on how you plan to use the stored data. And if we check the original data frame using df.hat, you will notice that the order hasn't changed because we didn't use in place equal to. If you use in place equal to when you're sorting, you don't need to call sorted value dot hat. You can just directly call the data frame like df dot hat, so you will get the results. Next, we will sort a data frame by multiple columns. Let's say we want to organize our data first by category in ascending order and then by price in descending order within each category. Here is the code: sorted value equal df dot sort values, under that by equal categories and price, comma, ascending equal to and false, and then sorted value dot hat. Here by equal category and price specifies the columns to sort by. First we sort by category, and within each category we sort by price. Ascending equal to, comma, false controls the order for each column. True means ascending for category, false means descending for price. When you run sorted value.hat, you will see the sorted data frame with categories listed alphabetically, and within each category the rows are ordered by price from highest to lowest. This method is useful when you need to analyze data hierarchically, such as sorting products by type and price, or organizing sales by region and revenue. Sorting with multiple columns is a flexible and powerful way to structure your data. Next, we are grouping the data based on a column using Pandas. The code starts with df.group by products, which tells Pandas to group the row in the data frame by the unique values found in the product column. This means that each product will form a separate group. Next, .count is applied, which counts the number of non-null values in each group for each column. The result will be a new data frame where each product is listed along with the count of the occurrences or entries for the columns in the data. Finally, print group data displays the grouped and counted data in the console, giving us an overview of how many times each product appears in the data set and how many values exist for the other column. Next, we are not only grouping the data but also filtering specific columns for aggregations. Let's break it down. The first part of the code is df.group by product, which groups the data frame by the unique values in the product column. This means that all rows with the same product are grouped together. Next, total specifies that we only want to focus on the total column within each group. Instead of looking at all columns, we are narrowing down the total column for aggregation. Then dot sum is used to calculate the sum of total columns for each product group. This means we are adding up all the values in the total column for each unique product. The result is stored in group data, which will now show the sum of the total values for each product. Finally, print group data displays the output in the console. This will show each product along with the sum of its corresponding values in the total column. This approach is useful when you need to summarize the specific data point. Next, we are grouping the data and adding up a specific column. First, df.group by product groups the data by the product name. This means all rows with the same product are put together. Next, quantity tells Pandas which only wants to work with quantity column for each product group. Then dot sum adds up the quantity values for each product group, so it gives us the total quantity for each product. Finally, print group data shows the total quantity for each product in the output. This is helpful when you want to know the total quantity of each product sold. And you can apply the same concept to calculate other statistics like minimum, maximum, and mean for each group. For example, instead of using dot sum, you can use dot min to find the smallest value, dot max to find the largest value, and dot mean to calculate the average for each product group. Next, we are going to group the data by region and calculating the sum of two columns, total and quantity. First, df.group by region groups the data by the unique values in the region column, and total and quantity specifies that we want to focus on the total and quantity columns. So, instead of working with all columns, we just select these two columns to calculate the sum. Then dot sum adds up the values in the both total and quantity columns for each region. Finally, print group data shows the results, which will display the total and quantity for each region. This is helpful when you want to analyze sales and quantity data grouped by region. Next, we are going to apply different aggregate functions when grouping data. This allows us to calculate various statistics for each product like the total price, average price, and total quantity. Let's break it down. First, df.group by product groups the data by the product column. This means all rows with the same product will be grouped together. Then .ag for multiple aggregates. This .ag function allows us to apply different aggregate function to different columns in one step. It's a powerful way to get multiple statistics at once. And total price equal total sum. For the total column, we calculate the sum which gives us the total price for each product. And unit price equal price and mean. For the price column, I am going to calculate the mean which gives us the average price for each product. And total quantity and sum. For the quantity column, we calculate the sum which gives us the total quantity for each product. The results of applying this aggregate function is stored in group data. When we print group data, we get a table showing the total price, average price, and total quantity for each product. In the next example, we are sorting the group data based on the total price column. First, group data.sort values by total price. Sorts the data by the total price column. By default, it sorts from the lowest to highest. To sort from the highest to lowest, we add ascending equal false. This ensures that the product with the highest total price comes first. The result is stored in sorted value, which will now show the products ordered by total product in descending order. This is useful when you want to quickly find the products with the highest total price. Next, we are filtering the data based on a condition. The code df under that df price greater than 500 filters the row in the data frame where the price column has values greater than 500. This means only products with a price higher than 500 will be included in the filtered data, not 500, greater than 500. It means from 500.0001 something. So the result is stored in filtered data and we print it. We will see a table with only the rows where the price is greater than 500. This method is useful when you want to analyze or work with specific data that meets certain criteria like filtering products above a certain price. Next, we are going to filter the data to only show rows where product column is equal to laptop. The code df under that df product equal laptop checks each row in the product columns and keeps only those where the product is laptop. There is the results is stored in a filter laptop, and when we print it, we will see a table with only the rows where the product is laptop. And this is useful when you want to focus on specific product like filtering for all laptops in a product dataset. Next, we are filtering the data based on multiple conditions. The code df price greater than 500 and df product equal laptop. Instead of and, you can put O also. Filters the data frame to keep only the rows that meets both condition and means both conditions must be true. The price is greater than 500, which is specified by df price greater than 500, and the product is laptop, which is specified by df product equal laptop. You can't put just one equal, you have to put equal equal because it is matching one thing. And the and symbol is used to combine these two conditions, meaning both condition must be true for a row to be included in results. And the result is stored in filtered data, and when we print it, we will see only the rows where the price is above 500. And this approach is useful when you want to apply multiple filters to your data at once. And that's how we can sort, group and filter with multiple conditions, and sort with multiple conditions, and adding new column and dropping new columns, and so on. And it's a powerful way to focus on specific subset of your data. Thank you for watching, and don't forget to subscribe Learn with Mafaza.